First step when dealing with word problems, I mean, this is the essence of learning mathematics. It's not just doing worksheets and doing assignments for math teachers. That's not why we teach you math. The whole point of your education is to understand that equations and expressions can represent real life situations. And you can solve real life problems with mathematics. That's the whole point. When we slap a cap and gown on you when you're done with the Park West and clap and you walk across stage and grab that diploma, we're hoping that you kind of understand, hey, the reason why you did equations in Mr. Mungia's class is so that you understand, you know what, out in the real world there's these guys called engineers and they solve real problems using equations. That's the whole point. You probably never see another equation in your life if you don't go into engineering. Maybe. Maybe when you buy a home though, or maybe do some banking, investing, you'll see some equations there too. But that's the whole point. It's not just to do worksheets and assignments. It's to understand that, hey, out in the real world, equations represent real life situations. Here's an example. We got a drama club, right? They're going to put on a play. Well, actually, they did put on a play. And they earned $1,040 from this play. The first thing you do when we deal with the word problems, and you're going to write this on your notes now. I trust you have a good amount of space because we're going to take up a lot of space in our paper today. We're going to break this puppy down, this situation. The first step, put step 1. Let variables represent unknowns. Represent unknowns. Let variables represent unknowns. So we got some tickets sold. What kind of tickets are sold here? Is this the same kind of tickets or 2 different kinds, 3 different kinds? Adult and students. So there's 2 different kinds of tickets. Do you think the adults pay the same price as students? Probably not. The movies, you have your student ID, you can pay less when you go to the movies. You go to football games, you pay less. Different events, adults usually pay the most. And we can assume that here. Let's see. An adult, what gives it away that an adult ticket, it costs more? What sentence? The first, second, third, fourth sentence? The third, huh? An adult ticket costs twice as much as a student ticket. So the student ticket is $2. How much is the adult ticket? If the student ticket is $3, how much is the adult? So take the student and multiply it by 2 and you get the adult ticket price. But we don't know what price it is though. So step 1, we're going to let variables be the unknowns. I do not know what here. How much what is? Right. The adults only? Both. I know how many tickets are sold. I know 64 adult tickets were sold and 132 student tickets were sold. I know that. I know the number of tickets. I just don't know the price of each one. So we're going to let a variable, let means allow. We're going to allow a variable to be unknown. Watch. So let x equal, go write that down. Let means allow. Let it be. In one sense, we're kind of like playing God here. We're going to let a variable be something. We're giving a variable existence. Let x be price of, go Dodgers. Let x equal price of student or adult, don't matter. I'll put let x equal price of student tickets. I'll put ticks, student tickets. Right, Sanchez? You have something to write with? That is awesome. I got you. I got you. let Y then, let Y, Vega, what's the other type of ticket? Say again? Price of adult ticket. So let Y equal, I'm gonna put little hashtags. Well, not hashtags, little quotations, because quotation means it's exactly the same as above. Price of adult tickets. I got you, Sanchez, hold up. Adult tickets. Adult tickets. Price of adult tickets. So step 2, I'm going to put in red here. Create simple model. Simple model of situation. With boxes and words. Create a simple model of situation with boxes and words. Okay. Okay. Here's what I mean. A drama club earns 1040 from a 1,040 from a production. A total of 64 adult tickets and 132 adult tickets are sold. Okay. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents the situation. So what I want to do is it says write a system. So if it's a system, that means there's two equations going on. Let me write one model of this third line right here, this third sentence. An adult ticket costs twice as much as a student ticket. Watch this. Adult tickets, I'm putting a box and I'm going to write some words in it. Adult price equals 2 times student price. Student price. Notice that's a model. I put it in boxes. You agreed that you're doing it for me. If a student ticket is $5, how much would the adult ticket be? 10. You take whatever the student is and multiply by 2 to get to the adult. If a student price is $10, you multiply by 2 and you'll get the adult price is 20. We just don't know what the price is. But we know this is for sure the case. We call this a model. The adult price of a ticket is equal to 2 times the student price of the ticket. That's fair. You guys agree? It should be the same. Well, whether it should or not, that's a different situation, different question. All I'm saying is if that's true, if adult tickets are twice the student price, then this has got to be true. You take 2 times the student price, and that'll equal the adult price. There's your first equation right there of the system. And look at the second equation. Watch this. Number of adults, box, times price. Actually, I'll put adult price. adult price plus number of students times student price look at this. Number of adults, or times the price of the adult. That'll give you the money that you get just from adults. That's obvious. The number of adults times the price of the adult, that'll give you how much money you took in from adult tickets. Plus, if you add that with the amount of money from the students, look at number of students times the price of the student ticket, that's going to tell you how much money you got from the student tickets. That's going to equal, look at, total cash. I'm going to put total cash. The second model right here, just think about the logic of it. If you take the number of adults and you multiply it by how many tickets of adults bought the ticket, the price, that's going to give you how much money you took in. If you add to that, there's a plus here, add to that the amount of money taken in from students, that's going to give you the total money. Do we know how much total money we took in for this drama play? Where will that go here, the 1,040? Right. We already know 1,040 is going to go right here, the total. So we really have our system already going on. It's going to be two equations, and we're going to be able to solve for it. Watch this. Step 3. 3. Third one is just write the equations out and solve. I'll put it in green. Step 3. Write equations and solve. Write equations and solve. Let's do it. Look at the first equation, it's the first model. What is the adult price? Y. Remember we let Y equal the price of the adult ticket. So for the first equation, instead of writing that box, I'm going to replace this box, the adult price of a ticket, with what we allowed the adult price of a ticket to be. Y. Look at Y plus, or is it Y equal? Let's see. Oh yeah, Y equal. Look at Y equals, stay with me. Stay with me. This is exciting stuff. We're allowing algebra to do the work for us, to solve this complex life situation. Y is 2 times, what's the student price? Somebody besides Vega. X, huh? The student price, look at it, was X. The price of the student ticket. Remember we played God here? We allowed something to be something. X is the price of the student ticket. Y is the price of the adult ticket. Now, look at this. Y is equal to 2x. What? There's your first equation. Let's write the second equation now, because we're not in the system yet. One equation is not a system. 2 have to be a system, right, Quintana? Look at the second equation, it's right here, the second model. It's pretty messy, my chicken scratch, but it's going to be okay. Number of adults. How many adults showed up to the play? Nice. That comes from the word problem. Look at a total of 64 adult tickets were sold. So let me write 64. So I'm on the second equation now. 64 times the adult price. The adult price, we allowed Y to be the adult price. So 64 times Y. I'll just put 64Y. Look at that's this part. 64 times Y. Look at this. Plus, how many students showed up, Cortez? So look at this is 132. times student price, X. Look at X equals the total cash. 1,040, yeah. Are we in the system yet, Vega? Why are we in the system? How do you know? There's two equations. Do we have the tools to fight a system and then conquer a system? We do. You can do it either by graphing or by substitution. Why would I not want to graph this system? What is it about the system tells you, you know what, let's not do it by graphing? What'd you say? Right. Look at these big numbers. You're going to better have a lot of graph paper. We're in the thousands here. So let's use the different method I taught you this week called substitution. Step one's already done, huh, for substitution. I trust you see that. Step one, look at y is already by itself. Nice. That means the second equation, wherever I see y, I'm replacing it with y is. This is awesome. Dodger blue because they're going to win the National League Championship today and go to the World Series the first time since I've been 13 years old. Did you hear that? They haven't been in the World Series since I've been 13, since I was 13 years old, 1988. So you're going to see a celebration like you've never seen before tonight if they win, and the champagne, when they bust out the champagne in the locker room, it's going to be crazy. Dan, I'm going to give you an extra nasty quiz tomorrow. I'm going to be pissed. I'm going to be angry. I'm going to let it on you guys. That's a good idea. No. Here we go. Y is 2x, so wherever I see y in the second equation, I'm replacing with 2x. 64 times 2x plus 132 times x is 1,040. Nice. Moving right along. That's second step of systems, right? Third step is solve for x now. Look at, we have an equation with just one variable. We're rocking and rolling. 64 times 2x is, I have no clue. 64 times 2 is 128, I want to say. Yeah. Correct me if I'm wrong. 128x plus 132x is 1,040. Like terms, 128 and 132, add those puppies, help. Is he right? Dang, Cortez is on it. Woo. Thank you, Cortez, for showing off also. 260x equals 1,040. Last but not least, right? Let's get x alone. Let's divide by 260. Again, this is why we're not graphing. Some nasty big numbers here. X then is going to be I don't know. Who's got the calcs? Come on. Should I bust out my smartphone? My Samsung? Is it 4? Be positive. All right, x is 4. Big deal. Let's go back to the word problem. What the heck are they asking? Let's see. What is the word problem asking? What? Look at. What is the price of each type of ticket? What was 4? Be specific, please. So x was, remember when we played God? What was x? X is the price of student tickets. X is 4. $4 to get in. So students, so let's answer the dang question. Students pay $4. The adults, though, was, let's see. Remember the adults was right here? Y is equal to 2 times x. The adult was Y, huh? Remember? Y was the adult price. So Y is equal to 2 times 4. So Y is, so adults pay $8. Beautiful. Will you see a word problem tomorrow's quiz? I'll probably give you a word problem as extra credit to get like an A+++, to jack your grade up nasty if you want.